Okay, welcome back. So now what this is going to be video entitled Mill Lab 7A, and what we're going to do is we're going to finish this part over here. To recap, we rough milled the outside contour with one tool, leaving 20,000 stock and two depth passes in Z, and then we finish milled it in one depth pass with another tool, and then we rough milled this pocket with one tool in one depth pass, leaving 10 thousandths in Z and 20 thousandths on the side of the pockets. And then we finish milled it with the same tool that we finish milled the outside of this part. All right. Now, let's see. I got pocket mill finish. I want to make sure if I had that down there. I do. All right. Remember the tool. So this is going to be tool 02. You're already going to have this in the control. In other words, you're going to have, when you go to the tool geometry page of the control, you're going to have 750 thousandths in there. So, but we did not use cutter comp here. There's no D number in here. There's no G40s. There's no G41s. We didn't have to do it. A lot of times it's just simpler. It really is. Okay, so what are we going to do now? Well, now we're going to go ahead and start drilling these holes. So let's add a space. Let's go ahead and get us a tool change block here. Remember, copy. Yeah. And I'll paste it right here. Okay, so let's double check this. Now, this is real important. Remember, we did a work shift. From here was X0, Y0 to do the outside. Then to do the pocket in these holes, we shifted the X0, Y0 to the center of the part. This has to be a G55, people. If it's not, you will totally screw this part up. It'll be totally, because it'll be coming from here, not here. And this is where we're calculating all our coordinates. We do have to do a very small amount of trigonometry. Okay? Oh my God, trig, now we're going to die. No, you're not. All right, so let's first off get on past that. Let me give you some line spacing here to get this up above that. So leave that G55 there. Okay, so what tool is this? Is this tool 2? It is not tool 2. What was the last tool we used up here? I think 3. Yes, 3, and then we went back to 2. So this is tool 4. This is going to be tool number 4. So let's go down, change our H number, tool number 4. Okay, this is going to be a number 4 center drill. That's all I need to put there. Control S. Okay, I always run my center drills at 1250. Okay, there we go. So we got that going. We got our H number, H number, speed, tool description. Let's see if we got anything else going on here. Yep, we got that the G55 did activate the work offset to shift to the center of the part. You need to do that every time. Remember, once you use a G55, since we're coming from the center of the part from now on. Okay, so Control S again, just in case you didn't do it. And I think I'm going to go ahead and resequence at this particular time. I hate that. Absolutely hate it. Copy. That's a predator editor should be here. Control A. Paste. Okay. I know it's there. I'll show you. Bob. There we go. And process, resequence. Okay. Boom. Pull it back up here. Control A. Copy. Minimize that. It's just best to leave it open. Go back over here to our lab. There we go. Go back up all the way here. Control. It's already selected. Just any place and paste. Now I should have all nice new sequence numbers. Yep. And hit Control S. I just like to do that on longer programs. You can resequence at the end. Some people it bugs, some people it doesn't. Okay. All right, so we got down here to tool change. This is where we last left off. Give you some blocks, bring us up here. And we're ready to drill these holes, which is going to be pretty simple. We have to do a little bit, like I said, a little bit of trigonometry to come up with our hole locations. Now I'm just going to say, I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8. And if you look over here, so what it says again, 8 500,000 diameter holes through. And yes, that is how you spell through in a print. Equally spaced, that means they're equally, whatever it is from here to there. 360 degrees divided by 8 is 45. Each one of these holes is 45 degrees apart. Okay, on a 3-inch 500,000 diameter bolt hole circle with a 20,000 chamfer per side. Chamfers are when chamfers are ever expressed like that, they are always going to be expressed per side. They will not say it, but that's what they mean. Okay, you'll have to take another print reading class, people. You just will. Okay, so what are we going to do here? Well, if there was there's some things I can copy. I can always copy this because this is a good right here. Fine, so we'll copy that because that's good. If you haven't noticed, that's pretty much the way we always do that, paste. So we went to x0, y0, which means it's going to go to the center of the part first. Z.1, turn the colon on. New line in 850. Let me see, 850. We'll keep it straight here so everybody can stay. Okay. Well, what are the coordinates of these holes? Last time I gave it to you you're going to have to come up with this. This is how you're going to do it. Now, this hole, hole 1, again, 1, 2, 3, 4, 5, 6, 7, 8. That's the number of the hole. So hole 1, hole 3, hole 1, 2, 3, 4, hole 5, and hole 1, 2, 3, 4, 5, 6, 7. So 1, 3, 5, and 7 are given to you. That's right. Those are given to you. We're going to go to hole 1. Well, how far is it from the center of the part to the center of that hole? We're already at x0. We don't have to move x. We do have to. We're going to use a G81. So what are we going to do? Well, it's half of the diameter of the bolt hole circle. The bolt hole circle diameter is 3 inches, 500,000. So it's the radius, or half the diameter of the bolt hole circle. So what is 3.5 divided by 2? 3.5 divided by 2 equals 1.75. Oh, guess what? I'm going to copy, put it right here, paste. And if I left that alone like that, that'd work, huh? No, you got to put a Y in front of it. Always that. Control S. Remember, when you use a G81, a can cycle, the first thing we do is move it into the position. So it's right at x0, and it's 1 inch 750 thousandths up. That's where we want it to be. New line in 860. Okay, so we're going to time it to turn our G81 on. And we're going to go, I believe I told you this type, 3/16 deep. Okay. Our plane is going to be 0.1. Just almost always keep your R planes at 0.1. And then we need a feed. Now, I do 2.5 inches per minute. That is just something it works, especially with a cutting speed of 70. This will work fine. Control S. At that point, I've activated my can cycle. One of these days, I'll do that. And that is a standard STAND. Control S. Standard drill canned cycle activate. Forgot that right there. That's why I double check it, because if you don't, that's an error. It will not work. It'll try to read this as code and it won't work. Remember, any of your RIM statements, your comment statements, whatever you want to call them, I don't care. They have to have a parenthesis here and a parenthesis there, or the control will try to read them. All right, great. New line. Now, here's the cool thing. Let's go in 870. We have to go to this hole. And why is it cool? Because we use trig. We have to use trig. It's actually given to you. These holes are given to you in what's called polar coordinates. They tell you that it's equally spaced, so you know the degree apart. Each one is 360 divided by 4. I'll do it, or divided by 8. And then we have the radius. The radius is half the bolt hole circle. That's all you need to know, and of course you need to know the formula. You can look it up. I'm going to tell it to you. So let's just do it. Open this up. We want to go ahead and view scientific. Oh, I can't remember because I don't use this calculator. I think I'm going to hit sine of 45 degrees and enter. So here's the formula for finding this. We are going to take the sine of the angle between the holes. So let's come up with the angle between the holes first. How many degrees in a full circle? How many degrees are there in a full circle? Well, there's 360. Each one there's 8 holes and they're equally spaced, so divided by 8 will tell us the degrees that each is 45. So each one of these holes is 45 degrees from there to there, from there to there, from there to there, from there to there, from there to there. So you get the idea. All right. All right. So let me clear that out. 45 is just what I want. So I either have 45 sine or sine 45. Let me, can't remember. Oh, that's right. Okay. Nope. That's not right. Here's how you do it on this particular calculator. All of them are a little bit different. I'm going to put 45 in and then hit the sine button. Yeah, that's the sine of 45 degrees taken out to way too many places. I don't know why it has to be that freaking accurate. My TI 83 takes it out to 11 places in the display and like 30 something in its actual calculations. So I'm not counting them up. I don't care. So that's the sine of 45 degrees. Once we come up with the sine of 45 degrees, I just have to multiply it times the radius. Multiply it. Or, yeah, multiply it. Multiply it times the radius. Trying to remember how to say that right. I'm just going to take this number and multiply it by the radius. How's that? That sounds better. So the radius is half of 3.5. Well, if I remember right, that's 1.75. I'm going to store that memory store just to make sure. So 3.5 divided by 2 equals, yeah, 1.75. Then I'm just going to go this times, okay, memory recall, which there's my sine of 45 degrees, equals 1 leg. So that's, now which one is it? Well, I'm going to guarantee you that since it's 45 degrees, it's the same amount up as the same. Remember I told you this about 45-degree triangles. The length of one side is the same as the length of the other. So that's all you have to do. 1.237. I'll go 1.2374 just for accuracy's sake. I am not going to copy that and try to stick that in my program. That'd be stupid. So x is going to be 1.2374. Y is going to be 1.2374. And guess what? It's going to go to there. It's going to drill a hole. Let's go over that again. Control S. The G81. That's my depth. That's how deep it's going to drill. This is my airplane. That's how fast it's going to drill. You always move it into position of the first hole. We were at X0, Y 1.75. Cool, it's running. And what it did was it will start drilling 100 thousandths above the part. When it gets down 187 thousandths 5/10 below the top of the part, it will come back up to 100 thousandths above the part. It will drill at 2.5 inches per minute. You don't have to put that anymore. After this point, every single coordinate that it goes to, it is going to drill a hole using that right there. Okay, so I'm ready for my next hole. Next hole is given to us. I don't have to calculate it all. I don't have to calculate it anymore. And you're going, what, Randall? That's why I did a work shift. Huh? You'll see. You'll see. 890. All right. Well, I'm at y0, but I'm not going to put that in there because that's y0 right there. But x, well, x is half of that, so x was 1, and y is 0, because I'm right here, right at y0. So we drilled this hole. That's hole number 3. Now here, let's just do this, because everybody likes this. 1. I'm going to tab that. Up. This is hole 2. Okay, in 900. Now, this one, we already know it. We don't have to do it, but I will do it again to show you. Okay, I'll show it to you. I really will. So what I'm going to do is, and get back my scientific calculator. There it is, all on the way and everything. Well, let's just put it up here. It's such a big thing. All right. So I'm going to take the radius of the bullet hole circle and multiply that by the sine or the cosine, because it's 45 degrees, of the angle. Which again, let's just do, I'm going to use cosine. So, gosh, I can't remember, 45 cosine. Yeah. Notice it's 0.7071. Let's just say that. Now check this out. Clear. Sine. Oops, no. 45 degrees. Sine. It's the same damn number. That's because, remember, one side of the 45-degree triangle, same as the others. It's because cosine and sine are the same. So it ends up being the same as 1.2374. I'm going to get rid of that now. So, but this time since it's here, x is going to be, I'm already at x 1.75. I don't want to be there. I want to be here. X is going to be 1 point. You know what I'm going to do? I'm going to do this. I'm going to do this. Watch this. Again, I'm going to make myself smart. Oh, I just want all this. Copy. Paste. So I only have to change two things. I have to change this. Remember, I am down below it. So that's a y minus. And I'm going to go over here and go whole 3. Control S. Whole 4 given to us. Okay. Guess what? X is going to be 0. Yep, that's right. Here's right here. 1. This is, excuse me, this was whole 1. Okay. I'm going to change that. This is whole 1. This is whole 2. This is whole 3. That makes more sense. This is whole number 4. There we go. Control S. Okay. So 1, 2, 3, 4, 5. It's given to me. X is 0. I remember X 0, Y 0. We did our shift right up here, so it's right there now. So X is 0. X. Y is going to be minus whatever the radius of the ball hole circle is, which I believe is 1.75. I'll put 0 there. We really don't need to put the 0 there, but I did it. I won't. I didn't do it up there. I'm not going to do it there. I didn't even put a 0 point here. So you know what? Let's get rid of that. Control S. That's Cephaloreus. It does need that decimal point. Okay. I'll tab that over. Control S. New line. Alright, so what are we going to do? We're going to do hole number 6, which is this one. Alright, I don't have to do the calculations anymore. I've been given all this. I'm just going to do this again. I'm just going to copy and paste. Copy. This is why I did my work shift, people. Otherwise, all these dimensions I'd have to add to everything. Ugh, just too many problems. Too many problems. Change that to a 6 real quick. Hit Control S. This is going to be minus, yes. My x is also minus. Remember, anything on this side of the line is minus. Everything on this side is plus. Everything is this plus. So, all right, x is plus, y is plus. X is plus, y is minus. X is minus, y is minus. X, over in this quadrant, x is minus, y is plus. Okay. All right. So, let's see here. What I need to change here is this right here. That has to be a minus because we're hole 6 and that's in the minus quadrant. That's why I did that. Control S. New line. Okay, very good. So what are we going to do here? Well, we're going to do that hole right there given to us. At this time, y is going to be 0, but I always list x first. X is going to be the radius of the ball hole circle, and it's going to be a minus. Okay. That's not tab. Hit the tab button. Up. Control S if you haven't done it. New line. Okay, this one, again, we don't have to do any calculations. All of these numbers are going to be the same. We're just changing the signs. I'm just going to copy. Now, this only works with a 45, with them being 45 degrees. Otherwise, if you have more than that, it wouldn't work. Don't think this works every time. It just happens to work in this case. The y is not. X is minus. I'm up here. X is minus. Y is not minus. Control S. That is not hole 4. This is not hole 7. That's hole 6. Wait a second. This is 6. Let's get that right. 5, 6. This is 7. And this was hole 8. There we go. Control S. Now, so 1, 2, 3, 4, 5, 6, 7, 8. Remember, this is hole 1 right here. You always go to the first place your journal, then you call your can cycle. Then we went to hole 2, hole 3, hole 5, 6, 7, all the way. We have center drilled everything. Okay, so what's the next thing we always do after we initiate a can cycle and we're done with it? We cancel the thing. Please, for the love of God, don't forget that. If you do forget to do it, bad things happen. I'm not kidding. Okay, now let's bring this up here. What do I need? Well, I just center drilled. Time for a tool change, right? I'm just going to copy all of this. And there's a lot of people say, couldn't we put this on that line? You better put it up there. It's best to do it. Copy, paste, bring it back over here, hit Control S right away. I'm going to get rid of that. I don't need that one out. Okay, G55 stands. This is going to be tool number 5. H number 5. Okay. Okay, so what did I tell you we were going to do? Let me see here. All of that's good right there. Control S if you haven't done it. I haven't got the right spindle speed. So let's go down and see what I was talking. What am I talking about? Quarter inch drill. So we need to calculate RPM for a quarter inch drill. Real quick. I can get this out of scientific now. Back to standard. So I don't have to look at all of that. So 70 times the 0.82 equals this divided by 0.25 equals that. That does not look right. Let me try that again. 70 times 3.82. I'm checking my answers for reasonability. Divided by 0.25. That looks better. I don't know what I did. You saw it. I didn't. I'm looking down here and hitting my buttons. So, 1069 is as fast as we need this one. Something 1070. No decimal point, please. Okay. Great. Now I've got all this. What do you think I'm going to do now? Well, I know all these are good. So guess what? I'm going to copy and paste from here. I don't need that X0, Y0 anymore. You know what? If you want to, that's fine. A lot of people, like I said, would find that sulfurious. It is a really good thing for setup. We could put a block skip in there. I'm not going to. Let me hit some more lines, bring some of this up here. Okay. Now, I'm going to take 0Y0, so it goes to the center of the part. Coolant's on. Let's look up here. Did we do everything that we needed up here? This all looks good? Are you sure? It's not. What'd we forget again? Air. Control S. Alright. Now, and I'm even going to put that, I'm going to take this, put it down here so I don't forget it. Control S. I will resequence. Now there's some things I do need to change. So let's see what I said to do here. Using the center drill, step drill. So we're going to go all the way through. I got step drill using the G81, just a G81. Step drill with a G81. We're not going to step drill with a G81. I'm going to change this right now. G83. Okay. We're going to use a peck depth of, I can spell peck. Oh, let's say 125 thousandths ought to be fine. See, this I'm also planning my work, by the way. You didn't realize that. It's kind of what this is for. Control S there. We'll save that. Oh, let's just put down pack. Thank you. Control S. Okay, get rid of that. So, yeah, so we're going to, okay, there we go. So we got to calculate the feed and the RPM. We already got the RPM up here. We already did that. So we got to calculate our feed for our drill. Okay, because right here we're going 2.5 inches per minute. First off, we're going to use a G83. That's a peck drill cycle. The Z depth is going to be, we got to calculate up that. Let's do that first. So remember, the part is 1 inch deep. So we got to go deeper than that. Why? Because the drill won't break through. So let's clear all this out. So we take 0.25, that's the diameter of the drill, multiply it times 0.3 by the number 0.3, which that's a constant. The diameter times 0.3 give you the length of the drill point. That, and then add that to 1 inch. And if you're really worried about it, you could add 20 thousandths to it. How about 1.1? Nobody's going to get freaked out about that, I guarantee you. So Z minus 1.1 deep. Our plane is going to remain the same. This, though, we need to calculate our feed. So let's calculate our feed now. Clear it. So 0.25, that's the diameter of the drill, divided by 0.125, the decimal equivalent to 1/8 of an inch. Remember, we're going to use the 1/8 of an inch. For every 1/8 of an inch of drill diameter, it gives 2 thousandths revolution feed for drills. So there's 2/8 and a quarter. Oh my gosh, surprise. Then, let's go back here. 2 times 0.002 equals that. That's how many thousandths per revolution that drill is going to go down. So every time that drill goes around one complete circle, it's going to go down 4 thousandths. We have to convert that to inches per minute. So we multiply it times the RPM. Times, and the RPM was 1070. 4.28. Copy, paste, Control S. Okay, so my G83 is not quite complete. It's getting close. Now I got this standard drill. That's not standard drill. It's PEC. That's a PEC drill cycle. Why? There we go. PEC drill cycle. Control S. PEC drill canned cycle activate. Somehow I lost my, that's very interesting. I don't know how that happened. I had caps lock on and now it's gone. There. Okay. So let's go back to that G81. Folks, there's still something missing. We got the right depth. We just took the drill diameter times 0.3 and then added it to the thickness of the part and added like 25 thousandths for just in case, you know. Our plane can remain the same. Then we change the feed. So we use the feed once again. For every 1/8 inch of drill diameter, you want 2 thousandths revolution feed. So I put 0.25 divided by 0.125, the decimal equivalent to 1/8 of an inch. And I got 2, multiplied that times 2 thousandths, because there's 2/8 and a quarter of an inch, times 2 thousandths equals 4 thousandths. Multiplied that times the RPM to convert it to inches per minute, and I got 4.28. That is my feed for the drill. Now we know all these coordinates are right. There's still something not here. We need our Q value. That is the PEC value, Q. Now what did I say? Q. I think I said 100 thousandths. Let's double check. PEC depth of 125. Okay, so 0.125. Now there is a formula for calculating up proper PEC depths, but seriously, it doesn't work for every single thing. And bottom line is, the smaller the drill, the more you need to PEC it. The harder the material, the more you need to PEC it. The more accurate your locational requirements, the more you need to PEC it, etc., etc. PEC, the amount of PEC depth is just not written in stone, folks. It's more of a experience thing. This will work just fine in this material. That'll be fine. Okay, so what that means is it's going to go down 125 thousandths and go all the way back up to the R plane. Go back, and it'll just keep doing that. PEC, 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 and that clears the chips, and it also makes the drill last longer, lets coolant get into it, a lot of cool things. Okay, guess what? We don't have to do nothing else to this. I haven't hit Control S again just in case, but there, it's going to do all of that. It's going to do all of that. I've got that done. I just drilled those holes. So, time for another tool change. I want all of it. Now, you know what? To be honest, let's just do this all at once. We're getting to the point where you understand that. I mean, didn't get it all. I'll just keep it the way I've been doing it. You don't have to do it like this. I'm doing it just for teaching. I would copy the whole thing. Okay. Now, let's get us some lines here. We'll resequence in a bit. So that was tool 5, so this one's tool 6. All right, so H6. Now, what did I tell you to do with the tool number 6? I'm going to guess countersink. No, we haven't finished it yet, so we need to drill it. Okay, so ½ inch, we're going to use it. This one is where we should use a G81. I got that confused. I don't, when you peck the first time, you don't need to peck the second time. That would be stupid. There, so let me get rid of that peck depth. All right. Yeah. Okay, very good. All right, so H6, calculate RPM for ½ inch drill. We'll clear it. 0.5. Oh, excuse me. Clarity. How do you hit clear? Is there a way to delete? Nope, that doesn't work. I was just trying to figure out how to do it without using that button right there on the keyboard. So 70 times 3.82 equals this. This time I'm looking at it. Divided by 0.5. There's my RPM, 530, 539, 35. You can't copy that. Remember, you can't have a decimal point in your spindle speed. Control S. And this is not a number 4 center drill. And that means that this is a ½ inch drill. Control S if we haven't done that for a while. Let's go back up here because I'm going to get, so I left this. This was a ½ inch drill, so I forgot to change that. Control S. All right. Very good. Now we're in good shape. We've got all our stuff going on here. Don't look like we have our MO1s. Copy these. That looks good. Control S. Remember, I'm going to resequence all of this. I must not have got all that. Oh, I didn't copy. Yeah, I did. I just didn't copy it all. I just went down to... Okay. So, got that. Now I can copy all of this, which I will. This is for my ½ inch drill. Now I'm going to get it all this time. Go right here, and we're going to paste. Okay, this is going to be a G81 again, so let's go back to G81. Don't need a Q value. Get rid of that. No such thing as a Q value of the G1. You will get an error. Okay, and this is standard drill. Control S. Let me double check that. Make sure I got all that right. Okay, very good. All right, so the G81, the depth is wrong, right? It's wrong. Yes, it is wrong. And what are we going to do? We're going to go ahead and change this. So let's go ahead and figure out how deep to do that. Clear it all out. So remember, the drill diameter, which is 0.5, times the constant 0.3 equals that. That's the length of the drill point, plus the thickness of the part, which is 1 inch. That's that. Plus maybe 25, just in case somebody didn't drill it right. So I want to go minus 1 inch and 25 thousandths. That is not right. I don't see how that happened, but that is not right. See, I'm checking my answers for reasonability. 0.5 times 0.3. See, it's got to be at least 1 inch, 150. Maybe I took it times plus, probably did that. 0.025 plus 1. I'm going to do that again. Yeah, let me double check all that again, okay? So 0.5 times 0.3. Oh, just great. Stupid calculator. All right. Click. 0.5 times 0.3. That's the length of my drill point. Plus the thickness of my part. Okay. Plus 25 thousandths. 1 inch, 175. Minus. So minus 1.175. That'll work just great. Control S. Got to change your feed. Highlight your feed. Go back in here. Let's do that again. So it's 0.5 divided by 0.125, the decimal frequency of 1/8 of an inch. Remember, we're going to use 1/8 for every 1/8 inch of drill diameter. We're going to use 2 thousandths per revolution feed. So there's 4/8 and a half inch. What a surprise! Times 0.002. What do you think that's going to equal up? So that is how far that drill should move in one complete revolution. Every time it goes around once, it's going to go down 8 thousandths of an inch. Now to turn that into inches per minute, multiply it times the RPM, which I'm trying to remember. I got the RPM at 535, so times 535, 4.28. Every now and then that happens, and it's just not a great rule. I'm going to try that again because I just can't believe that it's that way, but clear. 5 divided by 0.125 equals 4. What? Gosh. Oh, I got 5. 0.5 divided by 0.125 equals that. Okay. Times 0.002 equals that. Okay. Times 535. I'm going to double check my RPMs. You know what? I'm just going to run this at 600. I'm tired of that. 600 ain't going to hurt. Let's try that again. Clear. 0.5 divided by 0.125 equals that. Times 0.002 equals that. Okay. Times 600. 4.8. Alright, that sounds good. I like that better. You know, it shouldn't always do that, but there's something mathematically about that, because every now and then it does it and it always freaks out. It's done this twice now that I know of. Okay, let's take our G81. We got our Z depth, we got our R plane, that's never going to change. That's all we need. Everything else should be good. Okay, Control S if you haven't done that. I don't think I have. Okay, this is a G81. We're not pecking. We don't have to peck because I already roughed these holes out with what? The 1/4 inch drill, and I did peck it. So there's no reason to peck if you've already drilled it out. You know, seriously, there's not, unless it's a really big drill. Now you can change it and put a G83 and put a Q value in there. That's all you'd have to do, and everything will be fine. All right. So let's see. Excuse me. Back. This is what I meant. Jeez, oh Pete's. You can't have random decimal points in a program either, people. Alright, geez, I can't do nothing. Alright, so we're going to copy all our tool change block again. Alright, so here's my tool change block. This is going to be tool 07. Change my H number to 7. Okay, now let's see what I told you to do. Countersink. Running 300 RPM and 2.5 inches per minute feed. Well, that's as easy as it gets, isn't it? I shouldn't have done that. There. Okay. So, let's see. So I said 300 RPM. Remember, countersinks are run slow. On a manual machine, they run as slow as they'll go. So here we're going to go, okay, 300 RPM is pretty good. You know, that ought to work just great. This is a 90. This is going to be a 5/8. Remember, you can't countersink a 1/2 inch hole with a 1/2 inch countersink. So it's got to be bigger. 5/8, 90, DEG. Remember, the tool that creates a countersink is called a countersink, and the part feature that the tool created called a countersink is a countersink. Countersink makes a countersink. That's all there is to it. I'm sorry, not my fault. Do not feel like it is. Could have come up with another name. The 90 degree divided by 2 gives us that 45 degree chamfer that is specified right there. Okay. Yep. So Let me see what we got here. We got a G55. Remember, keep that there because we're still coming from the center. All right. I don't see anything wrong with any of that. That all looks good. Hit Control S. And let's add some lines here. Get this up above there. Okay. Now, we're just going to go back up and we're going to copy this entire block right here. Go down here and paste it. Of course, it always does weirdness. No, it doesn't. Control S. Alright, let's see what I told you. I'm pretty sure I did not tell you to use a G81 because the G81 has no dwell. It'll just go down. As soon as it hits its depth, it's going to come back up. So let me see what I said here. Countersink with a 5/8 diameter, 90-degree countersink running at 300 RPM, a feed of 2.5. I didn't change that. Use a G82. Drill with dwell. Please apply a 1-second dwell and a 20 thousandths by 45 degree machine for all holes. Okay. So let's go back up here. What do we need to do? Well, let's change this first. Okay. Turn it to a G82. Now, that is not right. You do that, you'll scrap the part. You'll countersink all the way through the part. Whatever, we got to determine what the diameter of the countersink on the holes is going to be. Well, if I got 20 thousandths on this side and 20 thousandths on this side, and this hole's 500 thousandths, that's 540 thousandths. That's the diameter. So you go this. Pretty clear, pretty cool. Clear. Here, cleared, I meant. So I got 540 thousandths divided by 2. The amount you go down is equal to the amount you go over. It's the same thing as a 45-degree triangle. That's how deep we go. Of course, it's going to be a minus value. I will copy that. I will get rid of you. And I'll go here and I'll go paste. And guess what? And I'll hit Control S. There's my depth. So I got G82. The R plane always is going to be point that. Now I said 2.5. There is not a really good standard rule for feeds and countersinks. The bottom line is the tougher the material, the slower you should probably feed. Maybe you can find somebody that's come up with one. I don't know about it. 2.5 works in almost every situation. For a G82 to be accurate, this is a drill with dwell. So let's go over here and change that. Standard, I'm just going to call it, we'll get rid of the standard. Drill with dwell can cycle. Control S. Okay, remember I'm doing that for you. I'm missing a P word. For every G82, there is a P word in here, and the P is in milliseconds. Now you can put the P any place, seriously. The controller will read it as it wants it, but again, it's a good idea to put it right after the R plane. P and 1,000, and that needs to be a capital P, by the way. Okay, Control S. That means when this is going to go, this thing will happen. First, it's going to wrap it to X0, Y0, turn the coolant on. Then it's going to go up to the first hole. Then it's going to activate the G82, which will cause it to drill 270 thousandths deep. Okay? And when it gets to that depth, it's going to stop for 1 second. The spindle will still rotate. That way you're ensured that you get a complete countersink. And I've had holes that have only been, with a G81, it'll go down there, get depth, immediately wrap it back out. And if you're going really slow, which we are because we're a countersink, 300 RPM, you will not cut a complete countersink. So you need a dwell. So there you go. The rest of it, guess what, is good to go. I'm going to hit Control S. That is all good to go. As a matter of fact, here's the beauty of it. This part is, again, I'm not going to say it. Yes, I am going to say it. This part is whooped. Control S. Now, I'm going to do this. Control A. I don't know why it does that. Well, Word does not do that. Copy it. Let's go into Editor. I'm just going to resequence my numbers. Paste. Let's make sure it did it. Process, resequence. That's cool. Okay. Look up here, should already be, no, Control A, copy. I'm going to turn this thing completely off. Yes. Do you want to save? No, I do not want to save the changes. Go back up here, this should be already. Any place on there, paste. Now let's go check it. Should have nice new pretty sequence numbers. Control S or those numbers will not be saved. At this point we're done. I don't see anything else that needs to be done. Looks like we're in good shape. We've done all that. Copy and pasting makes this a whole lot easier. So remember, this one, the thing, we rough milled the outside, we finish milled the outside, we rough milled the pocket, we finish milled the pocket. Then we did all the holes, we countersunk the holes. We also did a work coordinate shift. We started out with x0, y0 here, then we moved our x0, y0 to here within the program. It's a pretty simple thing to do. Okay, now there's more work with that G55. I'll tell you right here. You have to pick up 2 zeros instead of 1, and that's something that's a setup. Okay, that's a setup thing. That's a thing that you would do in a setup situation. All right, I don't see any other reason to continue with this. I think we're all done. I could put it in NC Viewer. We know the G83 and the G84s won't work, so it's really kind of serious. I've been trying Camatics a lot now, and I'll be honest with you, it's just not worth us using in this course. It's pretty. That's all it does. It's all it does. It's just pretty. So if you want to use it, that's fine, but it takes longer to set up. So, like I said, I'm pretty sure this is good. I might as well do it, huh? Yeah, I did mean that. No, I didn't mean VNC. I meant this one. I don't know why. Control A, delete. I should already have that in here. Paste. Plot. Okay. I'm going to go to the top view here. Boom. Certainly is looking weird from the top view. Go back to home. Yeah, guess what? NC Viewer does not recognize a G55 coordinate shift. So it tried to drill all the holes from X0, Y0. That's why they're not out here where they should be. Sorry, people. Things just don't always work out. You get what you pay for. This one doesn't cost nothing. So there you go. Get out of here. All right. That's enough, huh? I feel like it's